And for some, like the Gangetic river dolphin, they're critical to survival. As wildlife conservationists strive to save it, cutting-edge engineering lends them an ear. But how can acoustics technology give this endangered species a voice? That's a question of science. The Indian Institute of Technology at New Delhi is a hub for India's sharpest minds. They're dedicated to resolving the country's most pressing technology needs. One group in particular has been at the forefront of India's naval defense technology for the last 3 decades. The group is led by Professor Rajendra Behel, an underwater acoustics expert. This gives him special insight into how sound behaves underwater. What makes sound behave so differently underwater? Sound is a wave that uses particles of matter, be it solids, liquids or gas, to vibrate and move through. We hear things when sound waves travel as air vibrations and reach our ears, vibrating our eardrums and inner bones. But things change when the medium changes. Sound travels 4.3 times faster through liquid than air, making its journey far more speedy and efficient. And while we humans may not be able to hear well because our ears are designed for air waves, underwater sounds can be used in many other ways, not just to hear, but to see. That's where underwater acoustics experts like Professor Behel use strategies like sonar. He has dedicated his life to building navigation and communication systems for naval vessels.
One of our initial successes was in 1984 when we improved a Russian origin sonar system and which gave much better performance. This was very well received by the Navy, and since then we have been working on several projects of naval interest on sonar technology and on underwater systems and communication systems.
Sonar stands for sound navigation and ranging. Simply put, it involves measuring sound waves to detect the location, dimensions and movement of objects. There are 2 ways to do this. Actively, by sending out sound waves and allowing them to reflect off objects in their path. The time and manner in which sound waves are received back gives a measure of the target object. The other method is passive. It is simply measuring any sound waves coming from the surrounding waters. Sonar is a precise way to map underwater regions and navigate safely through them. By using sonar, one can create a picture of sounds where direct sight is difficult. Over the last few decades, Professor Behel and his IIT team have won many accolades in the field of defense. However, in recent years, focus has widened from matters of national security to matters of natural security. It all started in 1999. When Professor Behel was invited to Japan by a professor at the University of Tokyo, Tamaki Ura. But instead of collaborating on a defense project, his expertise was needed for marine conservation. It was a project studying the songs of the humpback whale.
It was the first time I was exposed to this kind of requirement. So we have to use underwater acoustics technology just like for submarine detection technology to listen into those sounds and to segregate them from the other interfering sounds from other ships and other marine mammals or animals, and to recognize those sounds and then say that from what direction the sounds are coming.
Professors Behel and Ura followed up their work on the humpback whale with the acoustic study of the Chinese river dolphin. It was a species that was already extinct, a fate that was staring another endangered species in the face, the Indian river dolphin.
So that idea was incubated in our minds. So So in 2004, when I finished my 2 years with Professor Ura, he said that we must establish a program of research for the Indian river dolphin.
The Indian river dolphin is quite different from its marine counterparts. It's a unique aquatic mammal, evolved to navigate the river's muddy water. It is completely blind, and much like naval submarines, it uses sonar to navigate and communicate. But Professors Ura and Behel weren't the only ones with river dolphins on their mind. Back in India, conservationists had a similar agenda along the Ganga. The iconic river Ganga occupies a central role in Indian life. It has poured life into the fertile plains of northern India, and millions find sustenance, both spiritual and material, on its banks. In recent decades, it's also become the most polluted and endangered river in the country. Today, it's posing a serious threat to non-human inhabitants, especially the Gangetic river dolphin. And so, conservationists like Dr. Sandeep Behra of the World Wildlife Fund, or WWF India, have put in long years protecting it. He's led an active campaign along the Gangetic banks of Narora in Uttar Pradesh.
This Ganges river dolphin is one of the 4 species of true freshwater dolphin found in the world. Basically, this Ganges river dolphin is found in India, Nepal, Bangladesh, and in the Ganga and Brahmaputra river basin.
Unlike marine dolphins, the Gangetic river dolphin has evolved into a blind mammal that navigates through the near opaque and muddy Ganges waters. It's the largest mammal in the Ganga and occupies top spot in this underwater ecosystem. But this esteemed status has not prevented its population from dwindling. At one time, these dolphins numbered in the thousands. Today, they've dwindled to a mere hundreds. What has caused this devastating loss? Large-scale pollution and dumping along with decreasing volumes of water have depleted its numbers. It has left conservationists asking, what will the river look like if the Gangetic river dolphin is not saved?
If this animal is cut off from this food chain, then the whole ecosystem will be affected. It is similar to that of the tiger. If we are conserving tiger, that is only to save the forest ecosystem. That's how we describe this river dolphin as the tiger of the river.
In an effort to save the river dolphin, conservationists have tried to visually track it. But that hasn't yielded very useful information.
These dolphins comes out of the water in every 3 to 7 minutes to breathe. So they are air breather. That is the only time when you can watch them and predict their behavior, whether they are trying to feed or migrating or anything. We were totally clueless about what is they are doing underwater.
Thanks to the sediment-thick water, optical tracking of dolphins is impossible. The question arises, how does one track an animal that can't be followed visually? The answer in a word: sonar. Back at IIT Delhi, the Japanese team has arrived from Tokyo. They represent the University of Tokyo and tech company KDDI. They're collaborating with Professor Behel's underwater acoustics group to track the Ganga's most endangered animal using sonar.
We are very interested in Ganges river dolphins' underwater behavior in high turbidity water, and also their acoustic performance. We hope the data from our system will be helpful for establishing a conservation program of Ganges river dolphins.
The Indo-Japanese collaboration has custom-designed gadgets to record the dolphins' ultra-high frequency sounds. What kind of sounds are these? And how are these different from human sounds? While the human range of hearing is between 15 Hz to 20 MHz, river dolphin frequencies are as high as 50 MHz. Blind underwater, dolphins use these high-frequency sounds for active sonar or echolocation. In echolocation, dolphins emit high-frequency sounds as clicks that move through the water. These clicks reflect off any objects placed in their path. The received signals help dolphins understand the shape, size, distance, and direction of the object's location. So how does Professor Behl's underwater acoustic system capture this sonar? The system consists of 6 hydrophones or underwater microphones that can pick up clicks. This hydrophone array, 4 in one plane and 2 in another, will be suspended from a boat. It will track any high-frequency sound emitted by passing dolphins. These sounds will be recorded, processed and analyzed by cutting-edge digital devices brought by the Japanese team.
So we have, as I said, there are going to be 2 arrays for monitoring dolphins. This is a number 1 system, this is a number 2 system. So there are 2 systems being tested, and there's a wireless LAN with which they can talk. We can talk to each of these systems sitting on the bank of the river, and so they're testing those configurations. We have also another system which is the acoustic imaging system. Like the TV camera that you're using is actually a visual image, it's an optical image, it's an optical lens, whereas this is an acoustic camera, it uses acoustical lens. So it uses sound to do the imaging. So we project sound underwater and we get reflections from the animals and the fish and whatever is there in the water. So they're ultrasonic images, just like medical ultrasound for looking at organs in the human body.
The acoustic camera is tested inside IIT's water tank. It records underwater sounds and converts acoustic signals into visual images. But why not just use a normal underwater camera?
We cannot see in the Ganges underwater more than few centimeters because the water is very muddy. So whereas with the acoustics we can monitor dolphin sounds passively, we listen to the sounds, and with this we can look at the dolphins, so to say, look in inverted commas, with the acoustic camera. So it's a unique pioneering experiment this time that we're going to do in Aurora.
Every lab simulation and last-minute check has led up to this moment, the early morning departure to Narora in Uttar Pradesh. Over the years, this WWF India office has become the headquarters for the national campaign to save the Gangetic river dolphin. Since 2008, it's included the Indo-Japanese Underwater Acoustics Program, the first of its kind to observe the endangered species world of sound. The team's first task, setting up the 6 hydrophone array and its framework. Once assembled, it will be mounted on 2 custom-designed boat rigs, which will allow it to pick up dolphin signals from different locations along the river. The boat rig will sail to the desired spot where dolphins are likely to be found. Here, the hydrophone array will be inverted and lowered into the water. It is now ready to track any dolphin movement through the water using sonar. So how does this array give us the dolphin's actual location? When a dolphin approaches near, it throws out ultra-high frequency sound waves, which propagate through water and reach the hydrophones. Here, each pair of hydrophones, 2 pairs in the horizontal and 1 in the vertical plane, mark the source of the sound waves. Calculating the angular difference between various readings gives scientists the exact location of the dolphin, how far it is from the array, and how deep it is from the surface of the water. And so, as the dolphin moves through the water, the hydrophone will track its pathway by reading its sonar at various points. So far, scientists have only seen dolphins as blips on a screen. But this time, the team is adding a new dimension. 3 dimensions to be precise. Since 2008, the Indo-Japanese collaboration has added newer devices to observe dolphins underwater. So what's on the anvil for this trip? Instead of a single acoustic camera, this time there are 2. When the dolphins swim past the underwater camera, it encounters acoustic or sound waves in the horizontal plane. This allows the camera to track the dolphin's length as it moves across. But what will happen if we rotate the camera by 90 degrees? It will give out acoustic signals in the vertical plane. Now, when the dolphins swim past, the camera will record its height. At Narora, scientists will place 2 cameras at a 90 degrees angle. This will ensure that as the dolphins encounter their sound waves, images will be captured in the horizontal and vertical plane. This will give them both the length and height of the dolphin. But not all gadgets are as complex or high-tech. Engineers have also gone low-tech with a compact dolphin detector kit.
The entire unit is totally portable. So if I switch it on and if there's a dolphin around, you will hear it audibly on the speaker, and so we can be cued to telling us that there is a dolphin in this area, and then we can localize it using the hydrophone array which is in front of the board.
So what exactly have we learned in the 5 years since the underwater acoustics program first began? Observations have thrown open the previously unknown habitat of the Gangetic river dolphin. For the first time, we are gaining insight into how they behave, communicate, and interact with their environment. Researchers are learning how river dolphins strategize using sonar in 3 phases. First, for searching and identifying objects. Then, for planning an approach route. And finally, for terminating the mission. Researchers also have new insights about the dolphin sounds. They've mapped different types of clicks from time intervals ranging from 10 to 100 milliseconds. They've discovered that sonar is used differently by young dolphins as compared to the adults. In another unprecedented discovery, the array has even stumbled upon a nursery for baby dolphins.
2 years back, there was a case when we could manage to locate a nursery of this dolphin near the village Karnabas. The mother nursing the young dolphin for around 3 months of its time, feeding the milk in regular intervals. So we could manage to see how this mother is carrying the child, the calf, a young calf, in a particular area, and after 3 months the calf started moving from that place with the mother.
The underwater acoustics program has opened a portal into the river dolphins world. Learnings from centers like Narora are a big boost for dolphin conservation. They've inspired WWF India to design and activate campaigns based on its findings. In recent years, such Save the Ganga dolphin projects have had a real impact on conservation efforts.
The result was fabulous. Basically, actually, I was not thinking that we will manage to get this good population in the state of Uttar Pradesh. And the population was around 671 in the state of Uttar Pradesh, which is quite encouraging basically.
And it's attracting the interest of researchers from around the world. The next big challenge for the Indo-Japanese collaboration was how to create worldwide access to this tiny boat rig at Narora in northern India. So in another first, this project allows them never-before access to real-time dolphin data.
That is the first time we are doing a real-time monitoring, and sitting anywhere in the world we can monitor and even command in a reverse manner if you want to change any parameters of the electronic system.
Being a pioneering project not just for India, this project has inspired others across the globe.
We will construct this kind of system in many rivers, for example, Indus River and Mekong and Irrawaddy rivers. And so that in this number of researchers is very limited. So it is necessary to have a network of researchers in the world. And I suppose that in Aurora, this area is the key center of such kind of networks.
But it's not all about science saving the animals. It's also about animals inspiring science.
This is the most apt species to observe or to learn from in terms of bioacoustics, because they do everything using sonar and we are able to observe them. And so I think there's a lot of scope to adapt their bioacoustics technology in a way in man-made technology for observation of the environment using sonars.
And so where modernity has taken away from nature, it can also give back.
This is one example only. There can be hundreds and thousands of such examples where science can come to the rescue, because diversity is the essence of life on this earth. And so we should live in a manner that is amenable and sustainable, not only for the human beings but also for the marine life around.
ये है दूरदर्शन नेटवर्क।